At this point, we move on to Lecture 9. This is the fifth of 5 videos where we're going to consider the fine art of proof construction. Proof construction is the systematic application of combinations of rules of logic that we've all ascertained are valid, that is to say logically flawless, so we can use strings or series of applications of these individual rules to prove that if a given set of premises are true, then a certain conclusion will follow from that set of premises. At this point, you should be well acquainted with the process of proof construction. You should be well acquainted with this process of line by line systematically increasing the amount of information you have to work with the goal of eventually deriving the assigned conclusion from the given set of premises that you have. At this point, you definitely don't want to be haphazardly just attempting to apply rules and hoping everything is going to work out. Instead, you want to be very systematic. Here are some guiding principles for constructing longer proofs. One of these, which has been mentioned already, break the proof into stages using the different letters, different capital letters, which indicate different types of information. In this first proof we're going to consider, there's A, B, C, D, E, F, and H related information. What we're going to want to do is make use of or get rid of, in some cases, and we'll see examples of both of these, the A, B, D, E, F, and H related information so that we're able to derive the appropriate C related information. So you need to look at the task of constructing a proof as a series of subtasks where each subtask is the completion of one of the stages. I would recommend, once you've broken the entire proof up into a series of stages, do the stages that look easiest to complete first. Because once the stage is started, you don't want to be moving on to another stage until you've completed the stage that you've started. And the way in which a stage is completed is by the application of one of the multi-line rules where you make use of information containing one or more of these basic letters. In this process, you should also get into the habit of looking for opportunities to do multi-letter stages. Finally, and we'll see examples of this in some of the proofs we'll look at later on, not in this first proof, if a particular uppercase letter occurs on more than 2 different lines, that letter is going to have a place in more than one stage. So with this in mind, we can look at our information in the premises. As I had said, we've got a series of letters. Now we have to decide which stage are we going to start the proof with. Deciding which stage to start the proof with presupposes that you are familiar with the implementation of the rules. Looking at this information, I would say the best way to start the proof is by focusing on the H-related information in lines 4 and lines 5. So we'll start off with the information in line 4. What we have there is a negated conditional. We've got De Morgan's for negated conjunctions and negated disjunctions. What do we do if we have a negated conditional? Well, we're going to use De Morgan's, but there's one setup step we'll do before we do the De Morgan's. Namely, we will do for implication on part of the line, the part inside the brackets, to change the conditional into a disjunction, and then we can do the De Morgan step. So on line 6, the conditional D horseshoe H becomes the disjunction tilde D or H by implication. Then we do a De Morgan's on line 6, which is now a negated disjunction, to get tilde tilde D and tilde H. We'll snap off tilde H with 7 simplification. Here, you might decide to also snap off the D-related information. I want to emphasize there's no requirement that you construct the proof in a way that keeps the stages as neat as possible. Thinking of the process of proof construction in terms of these stages is a very helpful guideline, but ultimately you're not required to keep the stages as neat as possible. All you're required to do is construct a series of individual rule applications, each of which is an application of one of the 18 rules to some subset of the available information. That starts off with your initial premises and ends with your conclusion. That being said, though, when I'm explaining the proof, I'll try to keep the stages as neat as possible. So, what we've done in lines 6, 7, and 8 is focus on line 4, and we've got tilde H, so that now we can end the H stage with 5, 8 modus tollens. So this will give us tilde E. So what we've done in the first 4 lines of this proof is strategically transform the information so that we can make use of and at the same time get rid of the H-related information. So we might want to just mark that off there. What should we proceed with next? If you notice, we've got the D-related information available by simplification from line 7, and we've also got E-related information on its own. If you look at line 3, one of the 2 sides of the biconditional is the conjunction of D and E-related information. So with that in mind, we will now focus on the D and E stage. To do that, we will start off with a couple of simplifications. 7 simp followed by, we don't need to do 9 simp. We've already got that information there. What we do need to do, though, is a little neatening up. 10 double negation will give us D, so that we can now do a conjunction 11 and 9 to give us D and tilde E. This will be one side of the biconditional. Now, we do the equivalent step, tilde F, horseshoe, D and tilde E, and D and tilde E, horseshoe, tilde F. So that's 3 equivalence. Equivalence is always the rule where you sometimes end up with lines that are a little bit long. Given that we have the conjunction D and tilde E, the conjunct from line 13 that is going to be most useful to us is the right one. So D and tilde E, horseshoe, tilde F will just be 13 simp, so that now, and this is what we've been setting up for the stage ending rule employment, 1214 modus ponens will give us tilde F. So ten, 11, 12, 13, 14, and 15 are going to be our D and E stage. Now that we've derived tilde F, the F stage is going to be pretty straightforward. It's only going to be one line. 215 modus tollens will give us tilde A. So now all we have to do is make use of or get rid of the A and B related information in order to derive C related information. Here, we need to use addition to introduce new B related information into the proof so that we can then make use of it and get rid of it. So this is just 16 addition. Now 117 modus ponens will give us tilde C, so that this is our A and B stage. So breaking up the proof, which ends up being 13 lines of inference, into stages makes the whole process much easier, because instead of having 13 lines in a row that we've somehow got to coordinate, once we break the proof construction process up into stages, we have the 4-line H stage, then we've got the 6-line D and E stage, followed by the 1-line F stage, and the 2-line A and B stage. So this should really go down to here. And this is the understanding of the proof construction process that you'll want to familiarize yourself with as you construct the various proof questions in exercise 413. In this second proof, we've got A, B, C, D, P, S, T, and W related information. And we want to make use of or get rid of the first 7 in order to end up with the W related information. So where to start? I would suggest we start with the first line because we have a negated disjunction which, once we apply De Morgan's to us, will give us a substantial amount of easily available information. So we start off the proof with 1 De Morgan's to get tilde A and tilde, then in brackets, B horseshoe T. At this point, we might decide that the A stage is the way to go, although when we look at our information, other information that contains A-related data, the conjunction A and C, which is the left disjunct of line 2, we can see that A and C related information are going to go together. In other words, the information that we have tells us we should do the A and C stage first. So we snap off tilde A, that's 5 simp. What do we need to do in order to complete the A and C stage? Answer, we need to have the negation of the conjunction A and C. Once we have that, the rule employment that's going to end the A and C stage is going to be disjunctive syllogism. So focus on that specific issue. Given that you have tilde A, how do you get the negation of A and C? Here's where familiarity with rule employments comes in. Here's the payoff from doing a number of exercise questions earlier. We do this strategic addition as we did near the end of the last proof, 6 addition, but this time we do it to set up for a De Morgan's, which gives us tilde A and C, and that's going to enable us to do 2-8 disjunctive syllogism and get the other disjunct, which now doesn't require brackets around it, which is W horseshoe tilde D. So we started off then and did a 5-line stage that gives us A and C related information. What's the most advantageous move to make at this point? The D related information looks reasonably straightforward. We've got D as the consequent of a conditional in line 3. Tilde D is the consequent of a conditional in line 9. So if we do nine contraposition followed by 10 double negation on part of the line, just on the antecedent of the conditional, we've now set up to do 311 hypothetical syllogism to get tilde P or T horseshoe tilde W. Now, unlike tilde A and C, a negated conjunction, Getting a negated disjunction is a little bit more difficult. We'll get it by De Morgan's, but we have to have both tilde P and tilde T in order to get the antecedent of the conditional in 12. So this is our D stage. What about the T-related information? If we look at line 4, we've got a negated conjunction, which is easier to get than the negated disjunction on line 12. So we'll focus on the T-related information in the next stage, and as we're going to see, the S-related information is going to come along as well. So our next stage then is going to be making use of, and at the same time getting rid of, both the T and S related information by the employment of one of the rules that you set up for. How are we going to do that? If you look back at line 5, that's where we're going to get the T related information. So we will do 5 simplification to get tilde B horseshoe T. We saw in the last proof that a negated conditional can be unlocked with a two-step sequence. We do implication on the conditional inside the brackets and then De Morgan's. So 13 implication and then 14 De Morgan's will give us tilde, and then in brackets, tilde B or T. Then 14 De Morgan's will give us tilde B and tilde T. From there, we snap off the T-related information, 15 simplification, and if you notice, there is no B-related information anywhere else in the premises. So rather than making use of, we're just going to get rid of the B-related information by not simplifying it from the conjunction in 15. So what we've really done in lines 13, 14, 15, and 16 is we have extracted the T-related information, which is useful, from the sentence where it's locked together with B-related information that isn't useful. All right, now we've got T-related information by itself. We want to link this up with the information in line 4. Here, we've seen how to do this from the procedure we carried out earlier in the proof. 16 strategic addition, 17 De Morgan's gives us tilde T and S. Now we need to do 4 equiv, which will give us a conjunction of two conditionals, tilde P, horseshoe, tilde T and S, and tilde T and S, horseshoe P. Given that in line 18 we have tilde T and S, the simplification we'll want to do is the right conjunct, tilde T and S, horseshoe P, so that's 19 simp. Now 1820 modus ponens gives us, little error writing this down. Good thing we caught this early. It's tilde T and S horseshoe tilde P, so that when we do the simplification, tilde T and S horseshoe tilde P, so that when we do the modus ponens, we end up with tilde P. So, let's keep them alphabetical. So this is our S and T stage. So all that remains is the P stage, which will give us the W related information. It's going to turn out, however, that there's going to be two different stages where T-related information comes into play, because if you notice, there's T-related information in the first premise, T-related information in the third premise. There's also T-related information in the fourth premise. So what we want to do is get tilde P or T, and that'll give us tilde W. Again, if you're familiar with the rules, that'll be a fairly straightforward procedure. So 1621 conj followed by 22 De Morgans, and we're able to complete the proof 1223 modus ponens to get tilde W. So this gives us our P stage and our second T stage. So in this particular proof, we've got 20 lines of inference. Starts to get a little tricky to keep in your head how to carry out 20 sequential lines of inference in an organized way. Much easier though if we've kept things in stages where we have a 5-line A and C stage, a 3-line D stage, the 4-line B stage where we're just getting rid of B related information, and finally a 5-line S and T stage, as well as we end off the proof with a 3-line P and T stage. And the reason that T occurs in 2 separate stages, as I noted earlier, is that the T-related information occurs not in 1, not in 2, but in 3 different lines of information. This is what we want to encourage when we're doing proofs at this level. You want to be organized and systematic in the way that you construct a sequence of rule employment steps, and the way to do that is to break the long sequence of 20 lines of inference into a number of stages where subtasks are completed at the end of each stage. Next, we can consider this 4-premise proof. This has P, Q, R, T, and W related information, and the conclusion is the simple sentence P. One other thing to note about this proof is that we have Q related information, not only in the first premise, but in the second, the third, and the fourth. There's Q-related information in every single premise. So there's definitely going to be more than one Q stage. It depends on the information we have. There may be 2 Q stages, or there may be 3 Q stages. We can figure that out as we go along. Another thing to note is that in the second premise we have Q and R related information right next to each other. That's all the information there is. In the third premise, though, we also have Q and R related information right next to each other. That tells us it's worth trying to start off the proof with a double Q and R stage. So what we've got in line 3 is a biconditional. So what we need to do then is take the Q and R related information in line 2 and make it either the exact same as this sentence here, or this sentence here with a tilde in front of it. Because we're going to end up, when we do equivalence, with a conjunction of mirror image conditionals. So depending on how this information works out, we will then just select the appropriate one. To set up for that then, so we've got it right in front of us, let's just start the proof off with an equivalence on line 3. So that'll give us T horseshoe tilde Q and tilde R and tilde Q and tilde R horseshoe T. Didn't leave ourselves a lot of room for the justification. That'll be 3 E Q U I V. All right, now we'll move our attention to the information in line 2. What we have here is a negated conjunction. In line 2 we have a conditional. So we'll start off converting that conditional to a disjunction. That's 2 implication. Now you might think we can just do a De Morgan's on line 6 to get, instead of a non-negated disjunction, a negated conjunction. One thing to notice though, look at the template. What we have in line 6 is not quite what we need to employ the De Morgan's rule. What we need to employ the De Morgan's rule, going from the right to the left, is a disjunction, non-negated, but both disjuncts are negated. We don't quite have that. We've seen in other cases though how we can get that just by doing a strategic double negation on the non-negated disjunct so that it becomes tilde tilde R. Now when we do 7 De Morgan's, we negate the whole disjunction, change it to a conjunction, and instead of putting a tilde on both sides, we remove a tilde from both sides, which will give us tilde Q and tilde R. Thus, in a 3-step sequence, implication, double negation, De Morgan's, we've got this exact sentence, which means we're going to want the right conjunct of 5. So 5 simplification will give us tilde Q and tilde r. If that, then t. So we end the first stage of the proof, which is a double QR stage, 8-9 modus ponens. So that gives us the simple sentence T. Now, if you look at line 4, we've got an opportunity to make use of the T-related information and introduce in order to get rid of the W-related information. Again, familiarity with the rules makes this fairly straightforward. From T on line 10, we do a strategic addition step. Then, since we want the negation of one of the disjuncts in 4 in order to do disjunctive syllogism, what we'll need to do is put brackets around line 11 and double negate the entire line. Now we can end off the stage 412. Disjunctive syllogism, which will give us the right disjunct tilde Q. So that's the T and W stage. So now all we have is the remaining Q stage. On line 1, we've got a biconditional again. So 14 we do one equivalence, so this will give us P horseshoe tilde Q and tilde Q horseshoe P. Given that we've got tilde Q on line 13, we snap off tilde Q horseshoe P, 14 simp, and finally 13, 15. Modus ponens gives us P. So there's our second Q stage. Thus, we've got 12 lines of inference. This time, we started off doing a somewhat longer double stage, but not that long. It's only 6 lines to make use of and at the same time get rid of the Q and R related information, or rather some of the Q related information. Then, given the information we had in line 4 and the new information we derived from the QR stage, we did the TW stage and then ended off with the Q stage. We can now move on to the following question, which I think you'll agree is the exact opposite of a user-friendly type of question. We've got a pretty broad range of information, G, H, I, J, K, L, M, and N related information, 8 different simple sentences where we have to make use of or get rid of 6 of those 8 so that we end up with I and K related information. With a proof like this, it's not exactly clear how we're supposed to start it. You need to be familiar with the rules. You need to have done a fair number of proof construction questions so that you can begin to think about the information you're analyzing in terms of those rules. Hopefully, you spotted the strategic way to start the proof. This is to do an exportation on line 3, which is going to give us L horseshoe tilde G. So that conditional is one of the conjuncts in the conjunction that's the antecedent of a conditional. The other conjunct, M, goes into the consequent, so that we end up with the following conditional by doing an exportation on line 3. This allows us to quickly complete a double stage 4-5 hypothetical syllogism, which is going to give us L horseshoe tilde G horseshoe L and J. So seems like we're moving along quickly here. We've gotten rid of 2 stages in the first 2 steps. Once again, though, we're sort of at an impasse. What exactly are we supposed to do now? Here, if you recall something I mentioned earlier, when you get to a situation where you're at a loss as far as how to continue with the proof, you're probably going to have to do a distribution. If you look at our information in line 6, we've got now 2 occurrences of L-related information, we've got G-related information, and J-related information. The 2 occurrences of the L-related information came from lines 3 and 4. There is no L-related information in lines 1 and 2, so what we need to do then is simply get rid of the L-related information. How are we going to do that? Well, we need to do a distribution. In order to do a distribution, we need to take the information we have and set it up into one of the distribution templates. So it's either going to be a conjunction or a disjunction. Since it's a conditional, it's going to be a disjunction. So with that in mind, we start off 6 implication, which will give us tilde L horseshoe tilde G, or L and J. Now, with just one step, we've got the sentence in a form that we can do a distribution. We've now got line 7, P or Q and R. The fact that the sentence we're putting in the P slot is kind of a odd one and a gated conditional. Doesn't stop us. So we do 7 distribution. What will that give us? Well, it will give us the following conjunction: tilde, L horseshoe tilde G, or L, and tilde L horseshoe tilde G. Not horseshoe J, but or J. So remember, our goal is to get rid of the two occurrences of the L-related information. We can get rid of one of them by just leaving the left conjunct up here. So we take down tilde L horseshoe tilde G or J. So that's 8 simplification. So in terms of the number of lines, we did one of the two L stages we need to do in only 2 lines, even though things were perhaps a little bit complicated. Or sorry, 3 lines. Now, how are we going to get rid of the other part of the L-related information? Well, the first thing to do is unlock the right disjunct. We've seen this a number of times already. We do implication on the conditional inside the brackets, then we do a De Morgan's on the negated disjunction, which is the left disjunct of this disjunction. So, tilde, tilde L, or tilde G. Now we do a De Morgan's. This is an interesting situation. There are 2 different kinds of De Morganses we can do here. We can either do a De Morgan's on the entire disjunct, which will give us tilde, tilde L, and tilde, tilde G. Let's do it that way. I just want to point out. Then you don't want to get dinged a small number of marks. There are 2 separate double negation steps to do on line 11. So the first one, we'll do it on the left conjunct in the left disjunct to get L and tilde tilde G or J, and finally L and G or J. Finally, we can do a commutation step on line 13 to get J or L and G. So we can now do a second distribution on line 14. Since we're starting off with a disjunction, we will end up with J or L and J or G. So that's 14 distribution. And once again, we can get rid of the second L by simply not doing this, the simplification step in the left conjunct where L is. So 15 simp will give us J or G. So The second L removal stage ended up being a little bit longer, but we were able to accomplish it. It was from lines 9 to 16, so 7 lines. Notice then, from line 7 to line 16, it took us 9 lines in total, 2 different stages to remove the 2 occurrences of L-related information from line 7 in order to end up with J or G. Think if you weren't thinking in terms of stages, you definitely don't want to be randomly looking for rule employment opportunities. We want to be very strategic. So now we've gotten rid of the 2 occurrences of L-related information. What do we do now? Hopefully, you've now noticed the rare opportunity to do 1 to 16 constructive dilemma, which will give us H and I, or H and K. So, after all of that work, taking us 9 steps to do 2 removals of L-related information, in a single step, we're able to remove, by making use of the G and J related information. Given that we want I and K related information, in the conclusion, all we have to do is focus on the H related information. You've guessed it, we've got another distribution. Here, handily enough, we've got the information in a form where we can do a distribution. This is the bottom right-hand side. We've got the disjunction H and I or H and K. Let me have a quick look. Where's that template? It's actually the top right-hand side, but this is the distribution situation we want. So, line 17, we do our third distribution in the proof to get H, the term that occurs in both of those conjunctions in the right-hand side, and a disjunction of the other 2, I or K. Then, just 18 simp. So it turned out our H stage was kind of short. So that ended up being 15 lines of inference. May I suggest, with a proof like this, too tricky to just start from the top down, having no plan in mind of how to strategically complete the proof in stages. Once you adopt a strategic, stage-oriented approach to proof construction, even a super hard one is going to be very doable. Let me repeat though, as we saw with a number of these stages, in order to do that, not only do you need to adopt the stage-oriented approach to constructing a longer proof like this, you also need to be familiar with those rules, very familiar, in order to successfully complete each of the stages. We can now go through a final review before test 2. For this second part of the course, we've got 5 lecture videos, lecture 5, 6, 7, 8, and 9. The first 2/3 of Lecture 5 focused on explaining the process of proof construction, and we started off in the easiest possible situation with the 4 of the rules that you set up for: modus ponens, modus tollens, hypothetical syllogism, and disjunctive syllogism. Assignment 5 is designed to familiarize you with this process of proof construction. Like so many things in this course, it's one thing to understand from a theoretical perspective the significance of the stuff that you see me doing. It's another thing, however, it requires a deeper level of understanding for you to be able to carry out those operations yourself. And the only way to get that deeper level of understanding is by actually doing various questions. So there are plenty of proof construction questions in that simplest case scenario. Then you can move to situations involving the use of all 8 of the basic rules. The final third of Lecture 5, as well as the first quarter of Lecture 6, demonstrates proof construction and some concrete hints involving the questions in Assignment 6, which consists of Question 6 and Question 7. From there, we moved on from the 8 basic rules to the 10 equivalence rules. In the second quarter of Lecture 6, all the way until the end of the third quarter, we focused on De Morgan's and double negation, as well as various aspects of the equivalence rules and their purpose, which are unique. Then, at the beginning of Lecture 7, I focused on commutation, association, and distribution. Exercise 4.6 gives you practice in double negation and De Morgan's. Exercise 4.11 gives you practice in constructing proofs with commutation, association, and distribution. Then, in the final part of Lecture 6, as well as the last 3/4 of Lecture 7, we considered the remaining equivalence rules, as well as proofs involving the 8 basic as well as the 10 equivalence rules. From there, we moved on to consider proofs that are a little bit longer, a little bit more difficult. They're described in the exercises as being moderately difficult. And then finally, in this video, we moved on to consider some difficult questions. So the moderately difficult questions are in exercise 4.12. The difficult ones are in exercise 4.13, which is assignment 8. The solutions for all 4 assignments have now been posted on the home page. I've told you this before, but just to review, Test 2 is going to consist of 5 proof construction questions. They're going to be questions just like the ones in the exercises. You'll be given a set of premises, and you'll be asked to demonstrate that if those premises are true, it's impossible for an assigned conclusion to be false. 2 of these proofs are what we might think of as basic proofs, like the ones in exercise 4.8. If you understand how to do these proofs, they should take you approximately 5 minutes each. Then there will be 2 questions that are at the moderately difficult level. Questions like the ones in exercise 4.12. These should take you approximately 10 minutes each. Finally, there will be one difficult question, like the questions in exercise 413, that should take you approximately 20 minutes. Added together then, you should be able to complete the questions in the exam in approximately 45 minutes. Recall that you will be given 90 minutes for the exam. So you'll be given more time than you need. You can think of allowing yourself half an hour for the last question, 15 minutes each for the two moderately difficult questions. That would add up to an hour. 7.5 minutes, let's say, for the two basic questions. That would add up to 75 minutes. So you will be given sufficient time, in fact more than sufficient time, to complete the exam. But in order to succeed at completing the exam, you're going to have internalized an understanding of how to construct proofs. And the only way to internalize that understanding is, first of all, review the various videos in order to understand the theoretical significance of what you're doing. If you're watching this video at this point, we can assume that you've gone through that theoretical process, but it's essential that you supplement that theoretical process with the practical activity of proof construction. So everything has been set out for you as far as the list of exercise tasks you need to carry out before the exam. So we're going to have the second exam in approximately a week, and if you follow this plan, you will be well prepared to succeed in the second exam.